In this problem, we are given a string and we have to use the characters of that string and form a palindrome. So we have to just return the length of longest palindrome that can be formed using the characters present in the given string. So it's one of the easiest problems related to palindromes. There are much more harder versions of this, like longest palindromic substring, which I have already covered, and longest palindromic subsequence. This problem is pretty simple, and I think it may be asked in as a warm-up question in one of the telephonic interviews. So let's understand it. So let's say you are given this string and you have to use these characters to form a palindrome. So if C is occurring 4 times, you can use C up to 4 times. So you have to return just the length. So in this case, A is occurring 1 times, B is occurring 1, C is occurring 4 times, and D is occurring 2 times. Now let's see how we will solve it. So if you see a palindrome, it can be of 2 types. One is that even length, and another is odd length. So these are the only possibilities. Even length can be like this: A, B, C, then the center will be here, not exactly at any character. Then we will have C, B, A, whatever was in the left part. Even odd length means, let's say A, B, C, D, or one or more of these characters. Let's say A, B, C, D, and this is the central character. And then C, B, A. So what is the takeaway from these 2 examples? One is that here exactly this part is same as this part. So every character that occurs here occurs in this side of the plane also. You can think of it as a mirror. So count of every character is even. So let's say A occurred 2 times, then this side also A occurred 2 times. So total it will be 4 times. So irrespective of whether A is occurring odd or even number of times in left side of the plane, we have to always double that. So here all characters, all chars C are even. Count of all characters C is even. And here whatever is present here, these are present here. So all these characters are occurring even number of times. But there is a central character. This will occur odd number of times. So if D has occurred here, then it should be here also. So D is occurring 2 times and then 1 in the center 3 times. All the other characters will be even. So all chars occur even number of times, and one character, the central character, occurs odd number of times. So what we will do, we will keep a map where the key will be the character and the value will be its count in the input string. So only one character can be center. So if every character has occurred even number of times, then we can use all the characters and form a even palindrome. If let's say some character occur even number of times, let's say A occurs 4 times, B occurs 6 times, C occurs 3 times, and D occurs 1 time. So these A and B, we will take everything. So divide them equally, 2A in this side, 2A in this side, 3B in this side, 3B in this side. Now we have a few characters which are occurring odd number of times, so only one of them can be in the center. If none of them are like this, all are even, then we are fine. If we have multiple or odd counts, then we will pick one of them as the center. Which one? It does not matter. So let's say if we pick D, so we will include D. And what is the remaining count? The remaining will be even. So if the count is odd, if we subtract 1 from that, it will become even. So whatever is the remaining, divide that equally. So let's say there is some more character F occurring 7 times. So let's say you make F, you put F here, then the remaining count will be 6. 6 more Fs are there. So put 3 Fs here and 3 Fs here. And for all the other characters which are occurring odd number of times, remove 1 from them. So basically what we are doing, sum of all even counts plus sum of all odd counts minus 1. We will subtract 1 from each and just take their even occurrences. We will put equal number in both sides and 1 we can make center. So if we have a choice, then we will always keep a central value and we will try to form a odd length palindrome since we want maximum length. So after these, add 1 to make the central character. So I hope this is clear, this formula. So all even counts, straight away we take it. All odd counts, we subtract 1 from each so that we can divide them equally. So their original counts minus 1. For each of them, we are subtracting 1 from each of them. So for this, we include 2. For this, we include 0. For this, we include 6. And finally, we are adding 1 to the overall sum to make it odd length. And this 1 will be conditional. This will depend on whether any character of odd count is present or not. How many of them are odd count does not matter. At least 1 should be odd count. Then we will add this 1. Otherwise, we will not add this 1. So now let's look at this example. What should be the length here? So even length are C and D. So straight away take 6. And we will have 2 C's here and 2 C here and 2 D's here. D is 2, so just 1 D, 1 D, 1 D. So these are done. Then out of these two, take their even occurrences. So subtract 1 from them. So 0, 0. So we don't include anything. So total is still 6. And now odd has occurred at least once. So we will add 1 in the end. So 6 plus 1 is 7. And you can form, what is that? 2C and D. So make it CCD. And this side DCC. And out of A or B, pick one of them. Keep them in the center. Let's say A or B. Both are valid. So its length is 7. So let's write the code for this. So the count map is ready. Now what we will do, result we will initialize to 0 and bool odd found. So whenever we encounter odd found, we will set it to true. By default it will be false. So if it becomes true, then we will add 1 in the end. Or let's make it C. So if the count, so this is a pair, we are iterating through this map. So this is a pair, second value is the count, first is the character. We are interested in just the count. If this is 0, then straight away add it. Else, if this is odd, then odd found becomes true. And result plus equal to we subtract 1 so that we take all the maximum possible even occurrence. And finally, if odd found, then we add 1. And the solution is accepted. So what is the time complexity here? So we are iterating through all the characters of the input string. So this makes O of n if n is the number of characters in this string. And then this is for the number of unique characters. So this will definitely be less than this. So overall it's O of n. And space we are using this counts for all the unique characters, and we can assume that unique characters are constant. So space is O of 1 and time is O of n. Now we will do the same thing in Java and Python. So if this is this character is being inserted for the first time, then it will take a default value of 0. If it's already present, then it will take the count and add 1 to it. So increment its count. And then result is 0. So we are just interested in values, and we can get that using values. And if and the Java solution is also accepted, and it's around 5 milliseconds. Now we will write the same thing in Python. So these are key and values. Second one is the count. So the answer is wrong, it's showing 0. The mistake is here, we are never updating the counts. So counts C. So we are getting and adding it, but we are not setting it here. That's the problem. And now it's correct. And the solution is accepted in Python as well.